Welcome to Intralogistics Insiders, brought to you by Synaos. Explore the latest trends, challenges, and innovations in intralogistics with industry experts. Welcome to the Intralogistics Insiders podcast. We have today Jana, Head of Robotics Department and Cognitive Systems at Fraunhofer IML. Welcome to the show.
Hi, nice meeting you.
So how did you get into the world of intralogistics? What's your background?
Well, I studied informatics at the Technical University in Dortmund with a main topic in robotics. And then I worked as a student at the Fraunhofer IML. And there I worked in a department which was focusing on mobile robots, especially for intralogistics.
What did get you into engineering? Why did you choose to go into engineering?
Well, it's a little bit interesting for me to have more insights about how everything is working. So I worked as a kid with computers and I found it really interesting. So I wanted to change a little bit how user experience in games can be modified. And then somehow I ended up in the field of mobile robots where you also have interaction with humans. And there's still a lot of research going on in this field.
Did you ever imagine that you were going to get to work with mobile robots?
No, not in the beginning.
Mobile robots was not a thing like 10 years ago. So
No.
It's quite new stuff.
Yeah.
So on your research department at Robotics and Cognitive Systems, what are the main areas that you are researching right now?
Yeah, so we have three main areas. So on the one hand, it's mobile robots, everything connected with robots like fleet management system, coordinating different types of robots, heterogeneous fleets, but also integrating manipulators onto the mobile robot platform. Then we have another focus on sensors, so everything which gives us information about the world, like 3D sensors, but also sensors at the human. So the human can wear, for example, a brain-computer interface to get some data about workload, about behavior, movement of the human. And the last focus area is about human technology interaction. So how to integrate the human better into the processes and how to adapt from the side of the mobile robot to the needs of the human.
The research regarding fleet management, is this something that is coming from the companies that work with Fraunhofer? Is this research inspired by the researchers themselves? Where does it come from?
Yeah, so it comes from both sides. I think when we talk about our customers, usually they are very interested in having a lot of robots driving on their shop floor. But the focus there is more onto a centralized system. And from the research side, we are still investigating how multi-agent system can be used. How do you have like a hierarchical structure? So partly centralized, partly decentralized. So it's a kind of both worlds combined.
What are the biggest challenges that you're trying to solve in that research group?
Yeah, so one big challenge is really having a fleet of heterogeneous robots which need to make decisions very fast. So you have problems in regards to standardization. I mean, we have the VDA 5050 right now, which is one step, but nevertheless, an implementation of a standard can be also different. The standard is not a standard, so to say. And another focus is really then on more how to act in dynamical environments. So you usually have a scenario from the customer side, and when you are developing something and trying to test it, there will always be something coming up which you cannot program in advance. So you have to have a very flexible system.
Okay. What are the kind of scenarios where you are developing or researching upon? Is this focused on industry, or are you studying also other spaces where robots could be used?
Yeah, so a couple of years ago, it was really the biggest focus on industry, like production, intralogistics, etc. But nowadays, it's getting more into the field also, like outside. So we have parts where the robot is at least driving between two buildings. We have also industries like the hospitals, like airports, the harbor, where everybody needs also automatization. And there it's the challenge is that you have people working there who are not used to robots. Or in a hospital, you have sick people there. You have hospital staff which are not engineers, and nevertheless should a robot be running around there.
should we consider that intralogistics as well, or is it a different world?
I mean, in intralogistics, it's people are more and more used to robots right now, or at least to mobilized, automized systems. So it's really different from people who are in the hospital.
Oh, that's true. What do you think is... Yes. So, for example, airports, we are starting to get into airports. You maybe see some mobile robots at restaurants, some restaurants.
Right, yeah.
At what adoption rate do you think we are right now in intralogistics itself? Are we in a stable area or still growing?
No, we are still growing. I mean, there are still scenarios where a couple of years ago you didn't have the abilities in the robot to solve these problems. For example, usually robots are driving very slowly. Nowadays we have fast robots which can run up to 10 meters per second. So this gives you the option to also handle use cases, for example, like sorting systems, where you just have automized sorter in a couple of years ago, and now you can do it with a robot.
So interaction with humans is one of the key elements of this integration of mobile robots in industries, both indoors and outdoors. You also mentioned that you are studying sensors. How important are those into being able to integrate mobile robots?
They are very important because you can then only handle situations which you couldn't plan in advance. So if you get information about the world, you need sensors, you need 3D sensors, cameras. They're getting cheaper, so you can integrate a lot of sensors into one robot. You can exchange data from a couple or a fleet of robots and just build up the digital twin of the world then with these sensors.
Now with heterogeneous fleets, one of the problems that arise is that every manufacturer makes, for example, their own maps with their own sensors. Are you also researching into how do we combine, how do we take profit of this and not having each one their own map with their own scenarios?
Right. Yeah, like you said, it's a little bit the issue from the vendor side. They want to be on a one hand exclusive. They want to have something fancy, which only they can do. But on the other hand, I think there are a lot of services like commodity services everybody needs and nobody's making money with them. So we are trying to find the sweet spot where it's important to have like open source development together with companies and exchange like maps, or at least have a standardization process behind that.
One of the things with sensors, at the end, you want to use them for perception.
Right.
And for sure, there are perception issues. No system is perfect. So how do you study and improve perception of mobile robots?
So you can do it in two ways. You can use, or you can come from the algorithm side. For example, you can use artificial intelligence, machine learning, only at these challenges where it's really useful, because I don't want to put AI into everything. And you can also use the human. What we are doing right now is using teleoperation, for example, especially to get very early into the market. Like I said, into a hospital, you have situations which you cannot plan in advance. So then we are trying to have a human worker getting information from the robot and then deciding, okay, here in this point cloud, I see an obstacle which you can move around, and then the robot can learn from the behavior of the human.
Okay, that's interesting. So we discussed about integrating fleets of heterogeneous robots. We talked about sensor perception. Most AMR and AGP manufacturers are using today lidars, cameras for the vision. They're using more, I would say, simple sensors like contact sensors in case they crash on one side. Is there something new that we should be aware?
I mean, cameras is, I think, really the way to go in many cases. Maybe also 360-degree cameras, because we have also robots which are changing their structure, so they are not having always like one lane of sight. If they are tilting a little bit, so you have a better view with 360-degree cameras. And with cameras, you can also do a lot of other things, object classification. You can also integrate sensors, external sensors, like sensors at the human. Using IMU is always common to get more information about the movement of the robot. I think LiDAR will become a little bit less, but more like 3D sensors, time of flight sensors, etc.
We're always talking about onboard sensors. Is research also pointing on the direction of not onboard sensors? For example, we could have cameras overlooking the entire operations and learn from those as well.
Yeah, that's definitely a way to go. It then depends on the costs you're investing. So you need to have a lot of, for example, cameras at the ceiling, and you need a stable communication layer. I mean, Wi-Fi, maybe 5G, 6G can help there. But yeah, that's an option.
So the third topic of research for your department was human-robot interactions.
Correct.
So can you tell us a little more about it?
Yeah, so we're focusing on different topics in human technology interaction. So on the one side, first of all, you can have sensors getting information about the human. I mean, you have to be sure that this information isn't used in a kind of bad way, secure way. But you can help the human then with these information. For example, you can have information about the mental workload, about is the behavior ergonomic, so having sensors at the human body to identify, is he bending down too much, is he over bending his knee or something.
What do you mean by behavior economics?
Ergonomics in a physical way. So having sensors at the human to identify then problems or with too much bending of a knee or something like this.
Okay.
And the other thing is you can have mental workload identified with sensors. You can use sensors to classify and gaining control over something. So identifying gestures, identifying speech recognition, so controlling then the robot with this information. We can also go from the other side, having the robot adapt to the human. This can be in a physical way, so slowing down because a human worker isn't used to working with this robot, extending the load handling device into a better position for the worker, depending on the height of the worker, but also user experience with the robot, user acceptance. So the design of the robot has a lot to do how people interact with the robot. We started in one research project where we developed a new robot, and it was more looking a little bit like, like in a movie. So it was more like a Terminator. It was very functional. It was very efficient. So everybody could work fine with the system, but people were afraid of it in a way. So then we took the same functionality, the same robot, just changed a little bit the design, like make it a little bit cuter, and the acceptance of the worker is rising. And this is also one thing that's really important when you put robots onto the shop floor. You cannot do it without integrating the human workers, which are on the shop floor, at the shop floor right now, working into this process. So you have to do questionnaires. What do you expect from this robot? What is helpful for you? Because it can be something very small, but which will gain so much more efficiency then as well. For example, we had a project coming up where robots should be helping the worker, like bringing some packages from the warehouse to a production site. And we asked, so what do you really expect from this robot? And what would be like a cool feature for you? And they just wanted to have a radio installed. And then we had the robot coming and it was playing music and everybody was like, hey, it's cool. It's they were happy. And this doesn't make any changes in the cost of this kind of robot, but it helps really to have human technology interaction making it in a better way.
The decision to implement mobile robots inside the company may come from a very different level of the company compared to the people that are working alongside robots. So this can be a problem in the long run because one could have made the decision based on the ROI or operational efficiency, but the other ones will have a different perspective. How do you measure this acceptance of mobile robots inside a factory setting, for example?
Yeah, so the first step is really to talk with the management level to tell them, okay, it's not only about the robot itself and the functionality, you really have to get your workers involved into this process. Because the management always tells us, okay, we are not getting enough workers. I mean, it's a skilled labor shortage, everybody knows. But nevertheless, the people are still working there. And it's not about taking their jobs. It's more about helping them or giving them opportunities to have another type of job profile, like taking away monotonous behaviors, taking away heavy loads, because the robot can carry this now. So then it's the second step is really to go to the people who are working at the shop floor, going into interviews, asking them about how they feel, asking them about little decisions. What do they want to have the robot, like in which design, in which colors? People give the robot's name then, so they're really, kind of building a relationship with the robot.
What do you think are the key elements that we should take into consideration for this good feeling between the people working with the robot and the robot itself, so we can make sure that we have a positive attitude towards the robot? What should we do before we implement the robots?
Yeah, I think it's really about also in the development process taking into account different types of backgrounds. So not only engineers, but also like a psychological point of view, taking into account design choices. Because, I mean, a robot is just another product and it has to be somehow not only functional, it has to be in a way fancy, good looking, like every other product.
There is always this saying that robots are stealing our jobs, you just mentioned. And many people say that no, it's just that maybe they do a different thing or higher value things. But are the same people that are today doing their robot's job prepared to do higher value jobs? Will they be able to scale their knowledge or what they're doing to do that? Or is it not the case? It will need to be other types of people that we will need in the factories.
Yeah, I think we have to focus, or we have to, I think we have to focus on this challenge from different types of views. So on the one hand, first of all, you do not have a lot of workers there anymore. It's not about like taking away jobs or changing a job profile. It's really that customers are coming to us and say like, okay, we're not getting any people. We are fighting like it's a not war of talents, it's a war of workers. I mean, we are in the production field. It's a dirty field. It's a heavy workload. It's mental workload. It's time efficiency, and people are preferring to work at, for example, restaurants, at McDonald's instead of working there. So there are really not a lot of workers right now. The workers who are there right now could be robots could help them on the one hand, so that they can do other tasks. They can learn also from digitalization, from AI, to be able to do other tasks. So it's not only about giving them more insights, teaching them something in school or something, but you can still do it while you're working there. Having sensors, giving them help while decision making. So telling them, okay, the pallet is not packed in the correct way, or here's a damage, can you check this? And the third part, I think, is about teleoperating robots. So also these workers can be, can gain insights and then can be used to teleoperate a fleet of robots in situations where usually the robot is not able to do the job.
This podcast is brought to you by Synaos, the all-in-one intralogistics platform, orchestrating material flows with mobile robots, forklifts, and people to overcome cost pressures and skilled worker shortages. Visit Synaos.com to learn more. Where do you see the future of this collaboration between humans and robots?
That's a tricky question. I mean, the future will be very various, I think, because there will be different types of robots working there. We will just look back where we were with AI, like in the 60s, 70s, and where we are now. Because people are used to have AI everywhere in their private life. And I think also robots are getting more and more into your private life. Like vacuum robots, yawn robots. So you're more used to these kind of robots, and also in the workspace you have more and more robots coming up, or more and more technology in general. You will have new types of robots, like more humanoid robots, where they are probably useful. There are still areas where they're not useful. You will have less workers at the shop floor, but workers who can work from home as well.
Just talking about the interaction on the current mobile robots that we have today, right now when there is an issue, the robot finds a pallet in the middle of a corridor, for example, you just have like a light, right?
Right.
An amber light or red light, safety stop, that's it. There's huge potential for AI here. It's not just a light moving around. It could tell you what is the problem, describe it to you so that an operator can solve it.
Right. Yeah, that's really helpful, because you get more data and you get more possibilities to show this information to a worker. You don't have to have only a red light. You can directly, for example, put something on the floor, like using a laser beam or something, to tell them, okay, this pallet needs to go there. You can use AR glasses, you can use other devices which the worker can handle, like handhelds or tablets or something like this. And you can also have the robot telling the worker, okay, I have a problem here, can you help me? So you can use speech recognition, gesture recognition to tell the robot then, okay, put this pallet there. So it's more like natural behavior from the human side, and use it with the robot.
The integration between mobile robots and manipulators, is this a thing of the present or the future?
So it's only in a couple of industries right now in the present, and it will become more and more important in the future. Right now we do a lot of research in this field. So we are trying to find these sweet spots or use cases where it's useful to have a manipulator on the mobile robot and do some additional tasks, like, for example, quality checks or mounting some parts in production lanes. However, right now the manipulators, they are still very cost expensive, and they have a high payload. So you really have to find the use cases for these types of fields. But it will come in the future.
Are there any technical challenges, either in hardware or in software?
Yeah, I mean, there are still challenges, for example, also in the sensors and data quality, because when you want to do a quality check and you're moving and they're like the floor isn't really good, and you have some bumps, and then the data will be not good, and you might misinterpret these data then.
So we are seeing a huge growth rate on mobile robotics in the market. For sure, if we want to really have full deployment of mobile robots in all industries, we will have to sort this issue of people and robot working together. I've heard, for example, some anecdotes on forklifts crashing into mobile robots, disputes around its use. Should we consider that this is a cost, or are there ways to improve this?
There are definitely ways to improve this. The cost will be then in advance, for example, in the design of the robot. Yeah, it's true, you cannot make the design, or you're not so free in designing a robot, especially when you have a pallet to transport or something. You're limited in your design because you want to have a small footprint or something. But you can integrate small things, like making it a little bit cuter by using different colors, by using displays. So we had one robot where on the display was just a face. It was just a box. It was really just a box running around, but it had a display with a face on it, and it was giving a name, and everybody was like, oh, that's Emily, how nice to meet you. And the small change then directly changes the behavior of the worker. So these are costs you can have in advance, but then they will reduce your costs by repairing the robot.
There is a huge growth of mobile robots, and that also involves that companies see it as a good market. So looks like we are having new mobile robots from different companies every day from all continents. So US, Europe, and especially Asia now is pushing also very strong. How do you see the market? Where do you see the difference between the different solutions being provided?
Yeah, I think in Europe, and especially in Germany, we really have to catch up. We have good research going on here. We have good companies, But like you said, there are different markets. Asia is coming, US is coming. And sometimes they have different types of regulations, because this is really an issue for us. I'm not saying that we shouldn't take care of regulation and about standardization, everything like this, but we need to have something running parallel. Because otherwise, humanoid robots are coming, for example, from Asia with sensors on them, which might not be secure, but they are a step ahead every time with development of software, etc. So right now, what we are doing is trying to focus all the research in Europe, in Germany, and combine it, not having like our institute working separate from other companies. So really exchanging, using open source, open hardware concepts to work together. We just started with the Robotics Institute Germany in this month, I think, where all the big universities and institutes are working together and opening their environments, so their testing environments to industry so that they can directly test at the research side.
Every day we see more and more women in engineering. This is true. But the reality is that historically, there has been more men designing these robots, designing the software, designing the tools. And maybe there is some influence also on how things are done today. Do you think we need more women in engineering?
Asking a woman, yeah, we definitely need more women in engineering. But we don't only need more women, we also need more diverse teams. So gender is one thing, age is another thing, cultural backgrounds, because especially when you're designing robots for not only one market, you have to take into account different cultural behaviors in human-human interaction, which then also has an influence on the human-robot interaction, for example. The design changes when having women integrated into this engineering process, and also having women more and more getting into jobs at the shop floor changes also the behavior, people behave with robots. So we're right now also designing questionnaires to get insights about how different types of people interact with the robot. We had a study going on, not taking only into account gender and age, but also the background. So it had somebody experienced with robots, and we tested the proximical distances. So how close can a robot get to you, depending on the size of the robot, depending on different velocities, depending on different designs of the robot. And how do human factors influence the distance? And one funny thing was that all people who had worked with a robot before or had experience with robots before, they kept a bigger distance. So they were probably, maybe they designed robots, maybe they had some crash with a robot before, so they were more afraid about robots than people who had never had any contact with robots.
So how can you get more people interested in robotics?
Yeah, you really have to start in the beginning. I mean, going to schools, we do a lot about getting students coming to us to show them that's not only about informatics and sitting there somewhere in the attic and in the dark and implementing things, but really working at the customer sites, getting into contact with other people. So to show that the job is very open to have different experiences. And as I mentioned before, going to schools, going to kindergarten to show people that engineering jobs, robotics is a cool field to work at.
We mentioned about, for sure, we need more diversity to make robots that are closer to people and all kinds of people. One of the next steps should be human robots. So where do you see the present and future of human robots?
Yeah, so you see there are a lot of companies investing into humanoid robots, but I think you really have to identify the use case. Where do you really need to have a humanoid robot? Do you need to have a humanoid robot working at a shop floor? Because the situations where the humanoid robot is useful is always in industries where we have a lot of workers. Because you have the environment designed for a human, and then you think, okay, if I have something similar to the human, then the environment is fine. But if you build a building from scratch, you can adjust the building to the needs of a mobile robot, for example. And it costs a lot of energy to have 2 legs, a humanoid robot with 2 legs. So do you really need to have each and every feature of this humanoid robot? Does it have to have eyes? Can it have other sensors? Can it have like wheels instead of legs, and can be still moving in a way like a humanoid robot?
We invented the wheel
right
a long time ago just because it was more efficient.
Right. Yeah.
And so it's weird that we want to put legs. The other thing that you mentioned that for me is interesting is, so we have these environments that are maybe better suited for human robots. But one question I have is, as of today, humanoid robots are intrinsically unsafe. Why do I say that? If you have an issue with a mobile robot with wheels, you just stop it. You have the STO, you kill the power on the motors, and it remains safe,
right.
More or less. A human robot, if you deactivate it, what happens? It just collapses. Yeah. 80 kilograms collapsing into someone maybe sitting down. So how do we go around this?
Yeah, I think this helps us in a way also, because when there's a lot of research done in this field of humanoid robot, you come to this question about safety. So you need to have sensors, you can have cameras, you can have like, I don't know, maybe an airbag or something, which then helps to reduce this kind of errors, which can help to reduce, to make it more safe, but which also give another view onto this whole topic of safety regulations. Because right now we started from designing machines, and our robots, mobile robots, are not only machines, they are different. So you don't need to have always a laser scanner. You have cameras which can be more efficient, which are used everywhere, which can also be safe. So the whole regulation process needs to change. And this is something where really humanoid robot research can help to make it faster in this changing world.
Do you see we'll have more and more humanoid robots around?
Probably there will be more and more companies coming up with humanoid robots. Seeing them right now or in a couple of years into intralogistics, I'm a little bit not optimistic, so to say, because like I said before, you have trucks, you have mobile robots which do the job right now there already. So why to use a really humanoid robot? There will be like combinations. For example, we developed one robot which is having wheels, but it has arms. So it can bend the arms, it can pick something up from the ground, our EvoBot, and can put it somewhere else.
So like 15, 20 years ago, there were companies already making humanoid robots. Like, for example, in Barcelona, there was PAL Robotics, we made mostly for research institutes, and universities were the ones who were working on humanoid robots. But very recently, probably thanks to Elon Musk, focusing on creating the Optimus, and with this like crazy price target that they put, looks like everyone thought, okay, if they think this is the next big thing, everyone is running to have one. But yeah, the question is, will this be real? There are a lot of challenges for sure that we have to overcome. But still, the implementation of wheeled mobile robots is still in the beginning. So thinking about human robots looks like so far away. Where do you think that mobile robots will see the biggest impact in the coming years?
So I think really mobile robots will have a big impact in last mile outdoor. So maybe in the beginning in the outdoor field at the company side, because then you have an environment which the company can have, can secure it in a way, but also later on in the last mile delivery. Because you see a lot of cities, they are so crowded, you do not have to have every Amazon UPS driver coming to your house. Maybe these last mile steps can be handled by robots. There's still a lot of things to do, especially in regards to safety and security. Another big topic will be this partly public part, like hospitals, like airports, where there are already some robots running around giving you like directions to the next gate or something like this. But they could also carry around your luggage, for example.
AI is in our daily lives from ChatGPT to generative models for images, for video. We have it to interpret data for perception. Where do you see the biggest impact in the coming years of AI?
Biggest impact. So I think it will change our whole way of working, because right now it's still a lot in the private sector. Like you mentioned ChatGPT a couple of years ago, nobody in the private life was really knowing what AI is or not using any AI software. And it can get more and more used in our everyday working life, like writing something with ChatGPT. There are challenges then. So can you trust the AI you're using right now? It can help a lot in the field of image recognition. But you always have to make sure where the data comes from. You have to take care of data privacy. You have to take care about labeling data, because we are doing a lot of training neural networks for our robots or for our use cases. But someone has to label this data in advance to tell the robot, okay, this is a box, this is a rack, something like this. And if you do not do it in the right way, you have bad data, and then you get a bad neural network.
Do we have a disadvantage in Europe? Because it looks like they always develop it in the US, with this fake it till you make it. Not fake it till you make it, but they have less regulations maybe. They can have more spit in what they're doing. And once we come into Europe, then we start putting laws into everything. And it makes it more difficult to develop, to create new companies, to develop new technology.
Yeah, I think I know what you mean, but also in the US, there are a lot of, or especially the companies are taking more and more care about regulations. For example, everybody around AI, also Elon Musk was signing some contracts to say, okay, we have to take care of what AI can do. We have to take care of ethical aspects. We did it in Europe with the AI Act, and we have to define these different levels in the AI Act more specifically, because you cannot say each and every data about a human is bad. Because I can use the data about a human worker to reduce stress for the worker. Right now, I cannot do it because the AI Act says, okay, you're not allowed to do it. You can use it for tracking efficiency of the worker and stuff like this. Yeah, so it somehow limitates us in the way of working, but I think it's nevertheless very important to always have this in mind, because AI is developing so fast, and once you have a neural network trained and in the world, you cannot take it back. I mean, the internet is everywhere, so once it's out, it's out.
What do you think will be the impact, or what is the impact of AI in logistics today?
Right now, AI isn't used a lot in especially not in small and medium companies. They are investigating about AI, so it can help a lot in the field of identifying errors in advance. So is the machine running in a bad way? Somehow you can check this by neural networks when you cannot see it in the data with the human kind of view. So there is still a lot of potential.
Is AI the new blockchain, and how we can differentiate between real AI and other things?
Yeah, so AI is in a way the new blockchain, because each and every company, everybody wants to use AI. And sometimes you just have a problem where you can use classical object recognition algorithms. They are very good. They are very efficient. They have been on the market for years. Nevertheless, the company says, okay, I want to have AI because I'm innovative. I want to show that I'm using AI. So you really have to also there have on the one hand or not limitate the company, because I think it's very good to have somebody be open to use AI, but you have to really think about, is it always necessary to use AI just because of the wording? Like you said, it's a kind of new blockchain. Everybody wants to have it, nevertheless, if it's useful or not.
Thank you very much for joining us, and hope to see you back soon. Thank you.
Thank you.
Thanks for listening to Intralogistics Insiders. Stay tuned for more insights and subscribe on Apple Podcasts, Spotify, or your favorite platform.